Let me explain why we cannot use the bigger of the two. Because if I use the bigger of the two, then I will have this interval, and I could possibly pick x here, and look what happens. That f of x is outside of the interval. So now, here is what we wrote last time. We will write it again today. For every epsilon positive, for every or any epsilon positive, I will find there exists, I will be able to determine, or there exists a delta positive, delta positive, such that, now I need to explain this, what this means. So when I picked x here, I picked it sufficiently close to 3. What do you mean by that? What do I mean by that? Delta close, not outside. So the distance between x and 3 is this little piece. So because x was picked between 3 and 3 plus epsilon. So then x is in this interval, or it can be on this side. It doesn't matter. So x could be anywhere between 3 minus epsilon and 3 plus epsilon. So the distance between x and 3, distance between x and 3 must be less than delta. Whoever showed up needs to be muted. Okay, muted. Okay, so distance between x and 3 must be less than delta. And this is how we represent this. This is the concept that I'm talking about the distance between x and 3 must be less than delta. The reason why you see this here is because x cannot be 3. And you can say, but we know that the absolute value is always positive. But what is missing here is the equal symbol. So this is specifically telling us you cannot pick x equals 3. You can pick anything you want between 3 minus epsilon, 3 minus delta, of course, and 3 plus delta, but you cannot pick 3. And we know that. How come I cannot pick 3? Because when x approaches 3, we cannot pick 3. Okay, finally, so for every epsilon, I'll find the corresponding delta such that when I pick x with the distance between x and 3 less than delta, it's guaranteed that f of x, the distance between f of x and 4, will be less than epsilon. The distance between, this is again the same idea, the distance between f of x and 3 is less than epsilon. So I think we should write the definition from the beginning till the end one more time and discuss it. And I can recycle that. And then we'll look at examples. And this is it. That's all I need in section 2.4. Okay. So let me write the definition with the numbers that we came up with. So the limit of the function as x approaches 3 from either side is 4. That was our example. I made it up. This was a function. I made up that I said that the limit is 4. And I also said that x approaches 3 from either side. This is equivalent to double equivalency. For every epsilon positive, we will find a delta positive such that every time we pick x with a distance from 3 less than delta, it's guaranteed that the value of the function at this x that we just picked minus 4, so the value, the distance between the value of this x, the value of the function at this x. And so the distance between that and the limit must be less than epsilon. So this is the epsilon delta definition of the limit, or called the precise definition of the limit. Let's look at the numerical example, and then let's do a proof from the beginning till the end. But first, let me take your questions, and I'll sip a sip of water. I have my mug here. Okay, anyone?
I just have a quick question for
Sure.
you.
Yes.
So delta is only seen on like far as like the x-axis, and
Yes.
epsilon is
X
the
and delta are together. F of x and epsilon are together with 4. F of x, the limit, and epsilon are together. X, a, and delta are together.
Thanks.
Thank you. Other questions?
Are we going to do another one of these examples?
Yes, this was not an example. I didn't give you the function. I just made up some stuff.
Oh, okay. Yeah, I just want to see it again.
So normally this will be L, this will be A, this will be A, and this will be L, as we wrote it last time. This time I just wanted to show with a numerical example, so let me write it again if you want. So limit of f of x as x approaches a is L means that for every and any epsilon positive, we will find a delta positive such that every time we pick x close enough to a, delta close within the interval delta, a plus delta, a minus delta, this will always imply that the distance between the function value and the limit, that's the distance between the function value and the limit, obviously must be less than epsilon. So this is again is called, this is the formal. This was just with a number in there, 2 numbers, so you know what I was talking about. Okay, now I'm going to share my screen to look at some numerical example. So let's look at number 2, because you have the answers for the other ones. So I'm going to look at an even number problem. Okay, use the given graph of f to find a number delta such that, it's a typo in here. My apologies for the book. It's not D, so it's delta. That's the correct symbol, not this. Okay? So I don't know if there is an error in others, but there is an error here. So it's not D, but delta. Okay. So use the given graph of f to find the number delta such that. Okay, so can anyone identify for us the limit? What is the limit in this problem? So this is problem 2 in 2.4.
Okay. 2?
Very good. Thank you. Can anyone identify for us lowercase a?
Is it 3?
Of course. Of course. Thank you. Can anyone identify for us epsilon?
Is it 2.5?
So epsilon, just epsilon.
0.5.
Yes, very good. Everyone okay with that so far?
Yes.
Good. So we don't have to do anything. We just have to look at the graph. Can anyone now give us the possibilities for delta? What are the options we have in this graph for delta?
0.6 or 0.8.
So one option is 0.8. And what is the other option again?
0.6.
0.4. Very good. The distance between 2.6 and 3 is 0.4. And the distance between 3 and 3.8 is 0.8. What did we say? I'm going to stop sharing because I want you to see how it's written. So delta must be the minimum of 0.4 comma 0.8. So then the answer must be
0.4.
done. Okay. So now I would like to choose an example. Where is my, you disappeared on me. Where are you guys? Okay, I see you. Now I would like to choose a linear function. I would like anyone to choose. You can choose any of these that are linear. You can use 19 and 20. So anything between 15 and 20 you choose. And let's show the actual proof with no numbers. So this was an easy situation in which we were just thinking which one to pick. Which one?
18.
18 it is, very good. I'm going to copy it and stop sharing. So this is limit as x approaches 1, 2x minus 5. They say it's -3. Is that correct? Is the answer -3?
Yes.
We don't trust anything. Very good. Awesome. It is. Good. So I have to write the equivalency, the double equivalency symbol. Every time I show if this is correct, and I use the epsilon delta definition because that's what the question is asking us, I have to write the definition. If you don't want to write the symbols, that's fine. You're going to have 5 rows of writings if you don't use the symbols, but it's up to you, of course. For every epsilon positive, I will find, or there exists, a delta positive, such that 0 less than. What do you think? Kush, how do I continue? Look at the definition and tell me how will you write it.
It's going to be absolute x minus.
So you're saying the absolute value, yes?
Yeah, absolute value. Is it going to be 2x minus 5? Wait. It's going to be x minus 5.
Mickey?
It's going to be 3.
Yen?
It'd be 1.
Very good. So we already talked about that this is x, this is a, this is the function, and this is the limit. Okay? Are you with me, everyone? Okay, less than. Oscar? Less than?
No idea.
Anyone? Jordan? Jordan?
Delta.
Very good. And this will imply always. How do I continue? Lindsay?
Sorry, I was muted.
That's okay.
That would go to. Oh, I was looking at the wrong problem. Would that be the -3?
It's going to be absolute value.
We are here, right? Are you following? Everyone, are you following?
Mm-hmm.
Okay.
Oh, I was looking at the wrong part. I'm sorry.
That's
That would be
okay.
the 2x minus 5.
Very good. 2x minus 5, and then? Trey?
Is it -3?
Plus.
Yes, but it's plus, right? It's minus the limit, and the limit is negative. Very good. Plus 3, an absolute value, less than. Isaac?
I don't know the actual name, but it's E.
Very good. Epsilon. Great job.
Okay.
Okay, so we have the definition now. Here is part 1 of the proof. We start from here. Starting point. Good. So can anyone simplify that starting point for us a little bit? So this is my page 4. Okay.
2x minus 2.
Very good. 2x minus 2. Very good. Less than epsilon. Now I stop for a moment and say to myself, what am I trying to do? I'm trying to get this. This is my target. This is my target. That's what I want to get. Because if I get x minus 1 somehow here, x minus 1 in absolute value, whatever I get on this side, it will be delta. So what do you recommend we should do next? What do you think? What can be done here? 10, what do you think?
Would we set it equal to 0 and solve for x?
What can be done here? We are not changing anything. We have an inequality with absolute value. What can we do here?
Factor out the 2.
Very good. That's all I wanted. So there is a property. There are two properties of absolute value. Because we have to use them, I want to review both of them right now. Here is one. The absolute value of a product is the product of absolute values. Same thing with a ratio. The absolute value of a ratio is the ratio of absolute values. How do I apply the product here? Because I have to write it as the first step. It's mandatory as the first step. You can say I don't need to because the absolute value of 2 is 2. I have to write it. It has to, yes.
It could be the absolute value of 2 times the absolute value of x minus 1.
Thank you, Mark. That's it. Now I can say, oh, it's redundant. No, we have to use the property. We have to, in other words, we have to show that we are using the property. Now you can say this is correct. And remember what I'm after. This is my target. So what should I do here? Jordan?
Do you divide by 2 on both sides?
Absolutely. Thank you very much. And now let's compare. This was our target. The absolute value of x minus 1 on one side and something on the other side. So what do you think delta equals to?
Epsilon divided by 2.
Thank you, Gio. That's it. Because this clearly states that for every epsilon, I will determine a corresponding delta. Delta must depend on epsilon. That's it. So if you say to me, okay, my epsilon is 0.5. Give me my delta. No problem. If you say my epsilon is 0.1, give me my delta. Okay, no problem. If you say epsilon is whatever, no problem. And this can go on forever. Why? Because the limit exists. Part 2 of the solution or proof. Show that delta equals epsilon over 2 works. I am not going to ask you to reverse the steps. Just write this by reversing the steps from above. Done. Steps from above. I don't want you to do anything else, but you have to write this. Why? Because we have to be conscientious of the fact that this says this implies this, this implies this. So we have to show both ways. But I'm fine with just this one sentence. Okay, let's choose another. And that's really all I had to say about this. Please choose any other problem so we can work on it together.
Can we pick either 19 or 20?
You choose, yes, whichever.
Let's do 20.
Very good. So this is 20.
Professor, I have a question. So for part 2, we're not gonna reverse.
You are going, if you want to, you can. You start, let me copy that so I can, so this is limit as x approaches 5, 3/2 x minus 1/2 equals 7. So let me stop sharing. Where is my mouse? The correct mouse is that. Let me start this.